Among the robots featured is this large design that was created by a team of CAM students and was successfully deployed in an actual robot competition.
We call it the big limit tester because its maximum requirements that we have, height, weight, and also it's pretty fast. So
6 foot, I believe, right?
it's 6 foot tall, yes, and it reaches about 8 feet in order to pass the ball on top of the overdrive.
Herman, you're with the build team, I guess, of this group, right?
Yes.
What does that mean? What do you do?
As the build chair, I have to oversee all the other build teams, which we have articulation, which manipulates all the field objects. We have the drive team, which builds the chassis of the robot in which you drive. We have the articulation team, electrical team, which will wire all the robot, make sure the battery is good to go. And we have the strategy and programming team, which they write all the code for the robot so that if we tell it to go forward, it does what it does. And I'm in charge of getting all the leaders of each team together and plan what we're doing and get all the designs of the robots done by the time that we have.
It sounds like you have a lot of people involved. How many?
Yeah, we have around 130 people. Each team, the build side has about 80 people involved and about 10 on each sub-team.
So it really takes a lot of people to get this little demonstration itself together today.
Yeah, it's a lot of work, a lot of dedication, a lot of time.
And it's 6.5 feet tall, and every time you make a lap, you can put a ball over it. And so we competed in a FIRST Robotics Competition.
During the afternoon demonstration, the Big Limit Tester has its limits tested numerous times.
Robot from scratch.
It is the same consistent performance that awarded the Robotics Club third place in the FIRST Robotics Competition held recently at the University of Southern California.
And then you drop it.
Came about through the FRC FIRST Robotics Competition, which is a national competition organized by Dean Kamen, who invented the Segway. It's part of a game which is introduced in January, and we're given 6 weeks to design and build an entire robot, which is supposed to pick up this red ball and toss it over a goal.
That was like the assignment?
We were given 6 weeks, and we competed along with thousands of other teams throughout the world, actually, which included teams from Israel, Mexico, and China.
Where did this take place?
We competed in Arizona and LA at the LA Coliseum by UCLA, or USC, sorry. There's also a national competition in Atlanta, which is at the Georgia Dome. There was a huge competition. There were 6 fields set up, and the entire dome was filled with people. Everyone was cheering. It was really exciting. Yeah.
What did you put it down on paper and toss ideas around as to how to actually create this monster?
Okay, that's actually my job. As a systems engineer, I work along with the other team of leaders to create a design process where the entire team of about 80 people present ideas, and then we do something called a design review or design analysis, where we decide which design is best based on its good and bad points. And in the end, we combined a few designs and came up with this one, which successfully picks up the ball and tosses it over the overpass.
How high does that have to toss it?
It uses a pneumatic system, which brings it up to about 6.5 feet.
And then over the wall, right?
Yeah, it has to go over a wall. Wall making loops, you have 2 minutes, and you have to make as many over in that time. You're also competing with 6 other robots, so there's a lot of contact. It's really a lot of driver practice. You're competing.
6 at one time?
6 at one time in one field, and they're all kind of roughing it up with each other.
It would be kind of nice if, there were another one on the other side catching it.
Yeah, that would be nice. Often the ball left and you had to go and get it back, yeah.
Though they may not look quite like the polished and streamlined robots of Hollywood science fiction sagas, the CAM's robot designs reflect the eagerness and innovation of their talented builders. With robotics such an important part of our future, and with organizations like NASA and Jet Propulsion Laboratory anxiously expanding their robotic endeavors, it is easy to see why youngsters are so engaged in this exciting new scientific frontier.
And it's pretty interesting. There's a lot of engineering opportunities for students. And as part of the robotics teams, I learned a lot of engineering skills, leadership skills as well. I've been part of the team for 3 years now, and after this year I'll be graduating, and I'm glad I joined the team.
It's unbelievably exciting. We have access to machines. We just got a few new CNC machines, which allow you to cut out parts after designing them on a program called CAD, which is a 3D drawing program. So you draw whatever you want using this program, and then you literally send it to the machine, and the machine will almost cut it out for you. That's how we did our big robot, the FRC.
So you really have an exciting life here, don't you?
Oh my gosh, yeah. The program that we're in called FIRST Robotics, we have our own team called the Nerd Herd.
Who came up with that anyway? Is that a positive thought? Or?
Oh, it's totally positive. We pride ourselves on being nerds, you know. But it's a huge team. We have 130 people, and it's actually 20% of the school is on the team.
A lot of our students go to four-year universities, they go to college, and a lot of our students from CAMS Robotics actually have gone to prestigious schools such as Stanford, UC Berkeley, Harvard, Yale, so that's pretty awesome.
So you have a lot of bright students here doing a lot of very interesting things, I see.
Definitely. We have lots of ambition for ourselves.
Now, when you go home after all of the schooling, I bet you continue your thoughts and conversation with the family.
Oh yeah. Robots are often dinner table conversation. You know, trying to come up with a design or you know, a problem. It's great.